Hello everyone, it's Valentine from Kimplistic, and what we're going to take a look at in this reaction is we're going to predict the overall reaction, and then we're going to determine the rate law that results from the following two-step mechanism. So whenever a reaction or problem is given to you where there's two steps involved in to form a reaction, you need to understand that each of these steps is an elementary step. Okay, so each of these are elementary steps. And what that means is that you can look at an elementary step and predict the rate law directly from the stoichiometry of the reaction. So you can predict the rate law by observation. All right, so once we understand that, let's go ahead and try to predict the overall reaction. So the overall reaction is simply adding these two together. And when we add these two together, the A2 cancels out. That's an intermediate in the reaction. And essentially what you have on the left-hand side is 2A plus B gives you, and then the right-hand side you have A2B. So that's the overall reaction. Now to determine the rate law, we only have to look at the slow step. Since the slow step is the first step of the reaction, that step is going to give us the rate law because the faster steps are going to just keep going. This is the step that is going to basically predict how fast the reaction goes. Now, what's important to remember is that the slow step, if it's the first step, that means if it's the first elementary step of the reaction, then you can directly look at this and predict the rate law. So in this case, the rate law is going to be rate is equal to rate constant K times the reactant A raised to the power 2, which is the coefficient. And that is the rate law. So at this point in time, this reaction, we just finished this problem. But it's important to remember that you may come across problems where these two steps are switched. So if these two steps are switched, then it gets a little more complicated because you cannot look at the first step, the fast step, and predict the rate law. So to understand that, we will likely create another video where I'll show you where the steps are switched and there is something called a fast equilibrium that sets in. That's a little more complicated than this. But right now, if you have the slow step being the first step and the second step is a fast step, then you can just go ahead and just directly look at the first reaction and predict the rate law. All right, I hope that made sense. Thank you for watching.